In this video we are going to be looking at carbonyl compounds, and the two examples of carbonyl compounds are our aldehydes and our ketones. And both the aldehydes and the ketones contain this functional group over here, where we have the carbon double bonded to an oxygen, and this group here is called the carbonyl functional group. Okay, so let's have a look at both aldehydes and ketones in a little bit more detail. We're going to look at how we can name them as well. So with our aldehyde, that carbonyl functional group is actually found at the end of a chain. So it must have the carbonyl functional group, and the carbon in the carbonyl must be bonded to at least one hydrogen. That's showing that it is at the end of the chain. And the other group can be any R group. It can also be a hydrogen, but that can be any R group there, any carbon chain there. Okay, so let's have a look at our simplest aldehyde. So it's where the R group is our hydrogen. So that's this compound over here. Let's have a look at how we're going to name this. So with this, we've got the longest carbon chain just has one carbon in it. So therefore the prefix is going to be methan. And because this is an aldehyde, all aldehydes are going to have the ending al, so Al. So they're all going to end in al. So this compound over here is just called methanol. So that's the chemical name for it. You might also have seen this as formaldehyde. So this is used as a preservative for biological specimens. Let's now have a look at another one. So the next one. So again, for an aldehyde, the carbonyl group has to be at the end of the chain. So looking at this one, we've now got two carbons in this, so therefore it's got to be ethan. Okay, and then again, because it's an aldehyde, it's got to end in al. So this one over here is just called ethanol. If we keep going, so it's like another carbon into that, you'll get the hang of this very quickly. So this one got 3 carbons, and therefore this one here is called propanol. Now you don't need a number to show where the aldehyde is, because it's always found at the beginning or the end of the chain. It's always found carbon number 1. Let's just have a look at it in skeletal form. So that's that in skeletal form. This over here is an aldehyde. We don't have to draw the hydrogen in. Just again count the number of carbons. So 1, 2, 3, 4, 5. So therefore this one here is called pentanol, like so. Okay. Now for our aldehydes, we also need to know the structural formula, how we show that something is an aldehyde. So in this one over here, if we do this in structural form, so it's got 1, 2, 3 CH2s. Now over here, so that's this part of the carbon chain that I've just covered, so CH3 and then 3 lots of CH2s. If we now look at this part over here, to show that it's an aldehyde, we have to write CHO. So we've got the carbon, the hydrogen and the oxygen. So anything that ends in CHO is showing that we have an aldehyde functional group present. Right, let's now have a look at our ketones. So ketones also have that carbonyl functional group, but now that carbonyl functional group is not found at the end or the beginning of a chain, it's found somewhere in the middle. Okay, so that means on either side of the carbonyl group we have to have an R group present. Okay, so that those R groups can represent anything as long as they are not hydrogens. Okay, so let's have a look at our simplest ketone. It's where on either side of the carbonyl group we just have a methyl group, like so. So this compound over here has 3 carbons in it, so it's got to start with propan. Okay. Now in this one you don't need to put the number in, because to make this a ketone, the carbonyl has to be in the middle. So all ketones are going to end in -one. So this over here is called propanol. Okay, so propanol is the chemical name for this. The kind of brand name for this is also acetone. So we may have heard of acetone in the form of nail varnish remover. So the reason why you don't have to put a number for this one is because if we have this carbonyl group on any other carbon other than 2, it actually becomes propanol. Okay, let's have a look at another one. So again, the carbonyl is not at the end of the chain. If it was at the end of the chain, it would be an aldehyde. It's in the middle, so therefore this is a ketone. Count the number of carbons. In this one, you've got 4, so it's got to start with butan. Okay. Now we've got to number the carbons. We've got to show which carbon it's found on. Again, in this one, you don't actually need to have a number because it's always got to be found on carbon number 2. So this one here is called butanone. As you can see, if it was over here, it'd still be carbon number 2. If it was on this carbon or this carbon, it actually becomes butanol. So we don't need to put a number in this one either. Okay. Let's have a look at another one. So one where we do have to put a number in. So anything with 5 or more carbons, if it's a ketone, you have to show, or you have to represent the number. Okay, like that. So this one over here has 5 carbons in the chain. It doesn't matter where we start numbering from because it is symmetrical. So 1, 2, 3, 4, 5. So 5 carbons mean it's got pentan to start off with. It's found, the carbonyl is found on carbon number 3. So this is pentan 3 one, like that. Let's now show this in skeletal form. Let's do an example. Like that. Okay, so again, number of carbons 1, 2, 3, 4, 5, 6, 7, 8. So therefore this is going to be octan. Now we should start numbering from this side to make sure the carbonyl falls on the smallest number carbon. So as you can see, the carbonyl falls on carbon number 2. So therefore this is octan 2 one, like that. Okay, now as the structural formula, so if I just do this part of the chain, so it's CH3, and then we've got 1, 2, 3, 4, 5 CH2s like that. Now when we get over here to represent the carbonyl part, where it's CO, and then we need to put the CH3 at the end. So all ketones, you will see this functional group in the middle of the structural formula, or somewhere not at the end of the structural formula. Okay, so that's what we're looking for a ketone. And let's just do kind of one tricky one, so we've already got other stuff coming off of it. So let's go for that over there. Okay, so again, longest carbon chain 1, 2, 3, 4, 5, 6, 7. So this is going to be, sorry, heptan at the end. So heptan 1, 2, 3. So heptan 3 one at the end. But now we need to do the methyl groups, the branches. So we've got 2, 4. I'm not going to fit this in. So it's got 2, 4 dimethyl heptan 3 one. Okay, so that's all one name there.